From now on, we're going to talk about the properties. Let's see. I select stir, then I specify the type, precast in place, then I open edit type. Here, in order to give you a complete instruction, I should duplicate a new type since I don't want to manipulate the type. So we assign the name str or stir1. After defining the name, it's time to talk about calculation rules. That the first option is maximum riser height, which is the highest that risers will not exceed when the stir run is created. And you can see the exact value of maximum riser height in the help. And as you're concerned, there are some standards of maximum riser height that we define them here based on the positions and places. So we specify the maximum value here, and we specify the actual riser height based on the number of the risers. And we got minimum thread depth, which is the smallest thread depth to use when the stir run is created. You can see the displayed in the help 280 for the minimum value, but the actual thread depth is 280. So if we specify 270, will be encountered with a warning message since it is less than the minimum value of riser depth. And the next one is minimum run width, which is the minimum or the width of the stir run. We specify the minimum value, and we can check the actual run width in option bar. That should not be less than minimum run width, so they can be equal with each other or more than the minimum run width. If we set 90, for instance, the actual run width should be 90 or more. So this was about this type. If we draw a stir here, that the maximum riser height is 180 and the minimum thread depth I set it to 250 or 25 centimeters, and for the minimum run width I set it 1 meter, and the total height of the building is 4 meters. So in this part, the desired number of risers, if I specify the value or the number of the risers, then the software will adjust the actual number of risers, actual riser height, actual thread depth based on the given values. If I set 22, we'll have a warning message since the actual riser height of the stair is greater than the maximum riser height specified in the stair type. As you can see, the defined actual riser height is greater than the maximum riser height specified in the stir type. So they should be equal or the value should be less than the maximum value. I define 23, and then for actual thread depth we have specify a greater value. I specify 300. Then I start drawing the stairs. I specify the first point, for instance here, and also the end point. 23 stairs or risers, and then let's see, we draw the section line, and then we open the section view. I put it here. Check this out. Then I want to select the stairs and open edit type. Here we got a property in calculation rules that we define or apply rules from a calculator to define the slope of the stair run. So we can control the slope of the riser. If we click on it, we'll get access to such a window, a stair calculator. Here these are specified based on the defined settings in instance. However, we can control it ourselves and customize it. But if we define something that intersects with the defined settings, we'll have warning messages. However, here we got the stairs created already. As you can see, here we got no warning messages since the stair is already created. But let's see how does it function. Right here, as you can see, we got a stair, 23 risers, 4 meters for height of the building. The depth of the tread is 300s, and so on. If I search in Google in calculator.net in a stair calculator, if I search for it again, watch this, I open a stair calculator, then we'll have such a window that we can calculate the number of these stairs, the size of the run or tread, riser, nosing. But before drawing these stairs, we can read about the slope of the stairs in different kinds of position, like in hospitals, in residential buildings, in complexes. I mean, we have to check them out based on these standards and see how does it work. Use one run. That here we got the guidance. As you can see here, we got the run that we got a tread in Revit. We specified the unit per meters, per centimeters. 30 centimeters for run, and then for total rise, which is the height of the level, which is 4 meters. Okay, I click on calculate. Then, as you can see, if 15 runs or steps of rises, then we'll have 16 or 15 runs. Then the angle will be 39.81 degrees. But here we got 23 runs. Let's see, 22, 23 rises, 22 runs. The angle is 30.10 degrees. So we open the section view from annotate, we pick angular dimension, watch this, 30.10. Here we got exact the same value. Okay, that was interesting. For instance, we can calculate the angle of the slope based on the number of the riser and run. Here this is called tread or run, however is called depth as well, and this is the riser of the stair, like this way. In the continuation, I select these stairs, and then in stair edit type, I duplicate the type, I name it O2. Afterwards, in desired, we set 23 and 280 for actual tread depth, and for trade our number of the risers we set 24 and 166 for actual riser height. Let me open edit type. If I check this, use stair calculator, as you can see, 2 risers plus 1 depth, the tread or riser start number. Here if we define the actual tread depth, then we can calculate the values. Let me get back to the website of stair calculator, and then I clear this since I want to calculate new values. The run is 250, the total size it rises 4 meters, and then I click on calculate. We got 24 steps here, 24 runs, or let me see, let me try again. 4 meters, 250, I'm sorry, 25 centimeters. I made a mistake. I defined it per millimeters. Anyway, if 24 runs or steps, or 23 runs or steps, as you can see, then the risers of 24, so this is the same, 33.69 degrees. And also we got the values for stringer length and height per inches. As you can see here, we got the height, the stringer height, and also the stringer length, or the length of the stair. Let us get back here. I open Excel. Wait for a second, please. I open a empty cell by this way. Let's see how many stairs do we have, or how many steps. 166.7. And for the actual rise height, and then for actual or tread depth, 250. Then based on the formula, I want to define equal to multiply in this, and I add it to C1. Then the value will be 581.4. Therefore, I have to define 581.4 based on the calculations. Afterwards, for maximum result for stair calculator, I set it 600s, and minimum result for stair calculator I set 550. We click on OK and OK. And if I draw the stair again and click on finish, let's check it out in the section view. And from annotate tab, angular dimension, then I measure the angle 33.69 degrees. Then let me check the angle in the website. Let's see, 24, 23, 33.69. We got the exact value, guys. So you can use the calculator, stair calculator, for controlling the angle of the slope of the stair based on the given values in a structural or dimensions, the actual number of stairs, actual tread depth, and actual riser height. We multiply 2 in risers, and we add it into the tread depth. Then we import the computed value in calculation stair. Then we'll have the angle. However, I recommend you to use stair calculator website to compute the value accurately.